there. The hashtag is ETWCM. And to shed light now on how to leverage new age digital insight solutions to transform into Enterprise 4.0, it's my pleasure to welcome on the dais Pratap Nair, CEO, Ingenro Technologies. Ladies and gentlemen, kindly put your hands together for Mr. Pratap Nair.
Thank you. Thank you. Can everyone hear me? So I guess the mic is working. Before I start the presentation, I'd like to kind of take you back a little bit, give you a little bit of history of where we come from, so that puts things in perspective as to why I'm making this presentation and why I'm qualified to even make this presentation. Ingenro, around 2001, we went out into the market to do offer data analytics services to be done remotely. Of course, we started this in the US, and at that time I remember a lot of people told me, hey, you're crazy. I mean, how can you sit halfway across the world, look at our data and our plants and tell us anything that we don't know? Well, time has told us that now we're working with several facilities all over the world. And we've been doing this, taking the data. We're connected to the plants. We're taking the data and doing the data analytics and providing almost continuous feedback. So this is a business model that we started and evolved. Things, of course, improved and evolved over time, and so that's where we come from. And that in those days, in 2001, I mean, no one was talking of Industry 4.0, but it was a classic application of industrial Internet of Things, or what I call industrial Internet of People. Because what IoT really does is enables you to take the data to anyone, anywhere. It's just that you have to get past the mindset of, yeah, we can do it. So what happened is when this whole digitalization movement started, we started getting called in by a lot of companies who either tried it and hadn't kind of quite gotten where they wanted to, or people who were really trying to get into strategizing what to do. And so we got involved with a lot of those, and that's really some of the experiences I'm going to share from what we learned working with several customers in this area. Most of the customers we work for are in the midstream refining, petrochemical, and chemical space. So it's process manufacturing has been our major client base, if you will, doing this kind of work. Yeah. Okay, so let me start with this, and I think we heard, I'll be preaching to the choir here, at least we heard this even from the panel. What is digitalization? Is really use of smart digital technologies, giving a more enhanced, intuitive experience, better intelligence to better monetize your resources, and at the end of the day, get you new revenue and value-providing opportunities. If that is not there, it's not worth even doing this. So the focus on digitalization initiatives with measurable business outcomes is extremely important. So whenever we go in, we say that, well, while this is how you execute, this is where you start the planning process. Figure out where your opportunities are, and those can be identified. And so it's not like this whole process of digitalization is only suitable for a certain size of company. The needs are there with any size of company. It's really what you're trying to address and how you're trying to address it with the subset of various technologies that are available. The value proposition from digitalization, increased production, increased yield, and for this forum, really the increased availability and reliability. So this is essentially what we go after. So we heard so much about predictive, prescriptive maintenance, and so on. So essentially, what this whole thing really does for us is, well, the equipment may be running normally, no problem, but then identifying very early in the life where the equipment has started deteriorating. If you identify it very early, you have time to be able to do something about it, versus finding out about it when it gets real obvious, where not much can be done. And so that's really what the whole application in the reliability area is about. In terms of data in this industry, what we've seen is there's no dearth of data. You have DCS systems. The only challenge really is there's a lot of volume of data that's available. It's a lot of different kinds of data that is being collected. And the key challenge is the veracity of the data. There are a lot of errors in the data. So when people say that, hey, if I have to use machine learning, I need very accurate data, never happens. So how do you work around that? How do you work in spite of that? And that is the key digitalization challenge. So I'll just kind of give you a very quick overview of what all digitalization entails. You start with the process manufacturing facility. You have sensors and plant OT. It could be directly from the DCS or historians, or you could have remote sensors. You have the DCS data historians. IoT enables that data to be taken wherever to the experts. Now, directly using this data for business intelligence is a very dangerous proposition, particularly in the process industry, because a lot of the times you don't have sufficient data, or you don't have the data that you want, or if you have data, some of them are very notorious, like composition measurements, analyzers. They fall off all the time. So just because of that, if everything breaks down, well, you have a problem. Then you don't have a digitalization solution. So one of the things that's really key in completing the digitalization is the analytics piece. The analytics can really help fill in the gaps. And so making the data usable, this analytics using various tools is a very important piece. The other important piece is impactful presentation of information. Now, both of these requires domain expertise and is a necessary set of technologies or systems that you need to be able to use the data for decision making. So at the end of the day, the goal of digitalization is to make reliable and timely information available so that you can get some value out of it. So starting from where we left off in the last slide, easily said, but how do you make this happen? There's a very important piece that often gets missed out, and we saw that with a lot of our customers when they initially started this. You don't just take the tools and expect that it'll automatically work, or you take machine learning or AI and throw data at it, get output, and voila, everything works. It doesn't work that way. There's a whole lot of what I call decision insight engineering that goes into making this usable. So that utilizes the analytics tools, whether it's ML, BI, first principles, decision insight engineering, all this combined. So this is kind of what we were doing manually, which today we are now converting into automated software solutions, which we have started implementing for a lot of our clients. So what you get out of that are overall performance overviews, which you can hang your hat on, reliable because you've sorted out the data, efficiency, and of course the reliability. So of course the base of all this, you really have fundamental models and ML and AI type of data-driven models. So that's streaming data and batch data, both being used. Just elaborating a little bit on what decision insight engineering, and a lot of people oftentimes miss it as something that is very easy to do. Well, the objective of manufacturing teams is to go from point A to point B with certain key performance indicators. Now, you have a lot of tools that we've all heard of, ML, BI, AI, IoT, a lot of tools. But the tools alone don't do the trick. You need to convert those into solutions using the data, and this is very important. Domain knowledge, software engineering, data science, it's a combination of these that go as part of the design insight engineering. And you have decision insight software that comes out of it, which is a solution that really gives you the augmented intelligence that is directly usable, which will enable the manufacturing team. At the end of the day, it's the manufacturing team that has to really implement and deliver. But this in the background is really what facilitates it. So just as an analogy, you have tools and solution. Tools are like atoms, solutions is like the molecule. So you really need the molecules at the end of the day to be able to really get your augmented intelligence. This whole process of having analyzed, taken the data, processing the data, doing the interpretation, doing the relevant analytics on it, and then coming up with intelligent this whole process is really, as a company, it helped us really be able to build solutions of this nature and provide the augmented intelligence that is required for customers who implemented this. So I won't go through this. It's a lot of detail here, but basically there's a lot of steps that go into this. There's data discovery, hypothesis creation, data preparation and orchestration, a lot of steps you go through. So it's not just taking a machine learning program, dumping data into it and expecting answers. A lot of even selecting what your inputs are, how you train the system, all that is very important, where domain knowledge becomes important. Of course, along with the software engineering, which makes streaming data, taking it and converting it, all that feasible. So these are some examples of decision insight software solutions, dynamic benchmarking. What this does is it takes data and automatically it shows you for the very same type of situation and conditions, have you operated better sometime in the past? And if so, let's go there. So it's readily available at your fingertips. Instrument drift identification. Moment instrument starts drifting, you get a message. Plant performance evaluation, early warning tracker, very helpful with reliability, equipment health monitoring. So these are solutions that we have been using as the base for this decision insight software that is being implemented. This is an example. By the way, we have a stall. You can get into more detail there. People can actually show you how this is working live. But this is an example of, there's an ethylene plant where we worked with. There's a dashboard that the operator sees. And by exception, he gets to see which part of his plant he needs to go focus on, where it's red. He can go drill down. I won't get into detail. You can get a lot more detail. You can drill down into the equipment and see exactly where the deviations are. And it gives some kind of a recommendation. Hey, this is where it's, your problem is likely coming from, and this is the possible fix. So at least he has something that he can start working from a different level, and then start implementing it. So we've done this kind of thing with different clients. The gasifier, the pertinent thing here, it enabled proactive maintenance, 7% improvement in asset availability, 30 days alert versus 4 days to take proactive action for a lot of, and this is a highly mechanical system, the gasifiers that you have, a lot of moving parts. And so this is something that came out. Some of these applications have happened, like I said, in the midstream, oil and gas field, ethylene plants. Everywhere, like I said, since we always started from knowing what the benefits could be and working backwards, we're always assured of the benefit when you actually go and implement the final solution. So earlier today, we heard a lot of people saying that, yes, analytics is a very important piece, absolutely, because that's really what takes you to the, what you're really looking for from the digitalization. Just getting the data and making it available, yes, it gives you the start, but analysis and analytics, how can you automate that? That is really where digitalization needs to be taken through. So to just highlight some of the concluding remarks from what I was presenting, these are key learnings that we also gained through some of our experience. The key objective of any digitalization initiative is to realize new revenue and value, rather than just doing it for the sake of implementing a new available technology. There is sufficient data available, particularly in the process manufacturing arena, and valuable intelligence and insights there are a lot of gems of information lying in that data, if only it can be extracted and used. You identify a lot of things. All you need to do is even one unforeseen error, if it can be identified, the type of losses that you overcome, it's huge. I mean, someone in the manufacturing will immediately be able to relate to that. Process data analytics is an essential piece in order to achieve this goal. Functionalizing analytics is easily said, but it requires specialized engineering work process called the decision insight engineering. Decision insight engineering is necessary to build the intelligence, to provide the augmented intelligence is really what you're looking for decision making. So that's really what all this digitalization can get you to. If you don't get this, there's no point. It's not fancy dashboards or something that you're looking for, but you really want to extract and glean value out of this at the end of the day. Success in analysis to provide decision quality insights by an analytics team is a necessary prerequisite. So this is something we found. Someone who's been through this, whether it's even if within your organization, you have people who've actually been doing this. So if you combine that with software engineering expertise and data science expertise is required, the key is to have this combination of groups working together in conjunction to be able to provide a solution like this. So that's, with available time, I just wanted to share what we've learned. So that's wrap up my talk. Can you speak up a little louder? Yes.
Accredited laboratories. Okay. Every year we are going to the laboratories and we are calibrating our standard instruments, with the help of which we are doing the calibration of our rest of the instruments in the plant. How many of all of us have analyzed our standard instruments which are being calibrated every year from laboratories? How much calibration is being drifted every year from the standard laboratories of our standard instruments? You are getting my question, sir? I have a standard instrument, and I'm doing the calibration of that instrument every year. So I am getting the certificate, and with the help of all those standard instruments, I am doing the calibration of all the instruments of my plant. So how many of us have analyzed the graph of our standard instruments for the last 5 to 6 years? How much drift we have got in our standard instruments? If there is a drift of 1 to 2%, so automatically that 2% is being shifted to your plant, because all those are the standard instruments. So this drift is very important, sir. So I am asking how we will ensure the drift in the instrumentation of the plant for readings.
Yeah, I'll give you a slightly high-level answer, but we can get into more detail. I can actually show you. There's our team here. Okay. But the broad idea here in all this is you're not just looking at an individual instrument and looking at a one-dimensional barrier or limits or boundaries that it's floating out of. You're actually looking at multi-variable behavior. And you're seeing sometimes that individual, there may be changes in flow rates that should not be flagged as, your instrument is drifting. So you have to see relative to the others how it's behaving. And so that's the basic concept behind it. But it's a lot of statistical, analysis behind that.
Sir, I do agree with you. I am giving you one practical example. A lot of people are here from the process industry, and the viscosity in the viscometer is only a calculation of pressure and temperature. I think you are agreed with me. Viscosity, in any viscosity meter, is a calculation of pressure and temperature. So, if the pressure is drifting by at least 0.1 bar in the pressure transmitter, the viscosity will be drifted by 10 to 15 centipoise. So, this is my example, sir. And with the help of viscosity, we are controlling our lot of processes. I think in a fertilizer, in the textile sector, and even in the chemical sectors. So, if the pressure will be drifted by 0.1 bar, 100 millibar, then the viscosity will be drifted 15 to 16 centipoise. And the viscosity is being controlled with the help of pressure and vacuum. So, this was my case because I had faced one problem. I calibrated by one instrument from the standard laboratory, and the accuracy of that instrument was plus minus 0.1%, which I have sent for the calibration. And the standard laboratory calibrated my instrument with the help of that instrument, which was traceable to international level. But the accuracy of that was 0.2. If the instrument, who is a master, having accuracy 0.2, how that particular instrument can be calibrated up to accuracy of 0.1? This was the case, sir. So I am telling you, we are believing on the standard certificates of the laboratories which are traceable to national or international level, but actually it is not like this, sir. With a single mistake, the whole of the instrumentation of your plant will be drifted because you are using the calibration, doing the calibration with standard instruments. This was the case, sir. You are getting
okay,
my...
We can talk more offline.
Okay, sir. Thank you.
Yeah.
Yeah, I think, it's just to be fair to all the delegates, and as Mr. Nair said, that question can be taken offline, otherwise it will get into a discussion. So to be fair to all the delegates, we are already running behind schedule. So sir, you can take your question to Mr. Nair. He has a booth outside, and I'm sure he has answers and detailed answers for all your questions. Thank you so much. Thank you very much. Let's have a warm round of applause for Mr. Pratap Nair.